Section 2.4, Part 2, Rates of Change in Tangent Lines. So in an earlier lesson, we talked about this first formula here, average rate of change, and we talked about how if I want to pick 2 points on a graph, and if I think about the line that's going between them, if I find the slope of that line, that gives me the average rate of change between those 2 points. We call that line that's between 2 points, we call that a secant line. Just a little bit of vocabulary. So the secant line from some point A to some point B, if we take the slope of that, we know what the average rate of change of that function is between those points. But what we now want to move to is figuring out how to find instantaneous rate of change. So what that means is basically we want to figure out what is the slope of our parabola at, say, this exact point. And when we do that, what we're finding instead of a secant line is we're finding a tangent line, which this isn't a great placement for that. Let me move it a little bit. See, tangent lines just touch at a point and only one point and then have the same slope as what our parabola does at that exact point. So what happens is that it's kind of like we're taking this average rate of change idea, this first line, and if I look at this tangent line I just drew, those slopes are actually pretty similar. But the problem is that if I pick a different point on my parabola to want the slope of, like say I pick a point that's up here, and so that slope is steeper for that line than what we approximated, or a point down here, this one is much more gradual. What we do, and what this formula here for the slope of the tangent line, what it does is it's the idea that we bring these 2 points on our secant line as close together as possible. In fact, we want to make them so close together that we can't even tell that they're 2 different points. And so as we basically take this point up here and we move it closer and closer and closer to the point we actually want to look at, and this point as well would move closer and closer and closer to this one, then what we're doing is we're finding a limit as our gap, which is h, goes to 0. So it's kind of a weird concept, and the theory behind it, not quite as important, at least for right now, as us learning how to do it. So we're going to use this formula in this lesson, and again, it tells us the slope of a tangent line at whatever x value they give us. These problems are going to be kind of involved, and so we are going to have a part A, a part B, a part C, and a part D, and part A is definitely going to be the toughest and take us the longest. So I'm going to recommend that we go ahead and graph this, negative x squared plus 2. It's not something that you have to do. I just would plug it into my calculator and look at the table of values, or maybe I remember how to graph it pretty well by hand. Whatever the case, we don't have to graph it before we do it, but there are a couple ways in which it'll actually help us if we go ahead and have it graphed. And part D asks us to graph it, so it's kind of like we're multitasking here. Here's a negative x squared plus 2. This is what I'm graphing. This is what I'm looking at. At x equals 1, that's this point right here on my parabola. So what we want to do in part A is find the slope of this parabola at x equals 1. So one of the things that's going to help is if we think about at 1, what is my function? So in other words, if I plug in 1, what do I get? Well, I can either look at my graph and see that I get 1, or I can plug in to my function and see that I get 1, whichever way I want to go about it. Either way, I get, when I plug in 1, an answer of 1. It's going to help us in a second on part A. So I want to find the limit as h approaches 0. If you look back at the formula, you have f of x plus h, but we know that we want x to be 1. So we're going to go ahead and put that in. And then minus, and then we have f of x in our formula, but we know that we want x to be 1. And it's all over h. So now I need to find f of 1 plus h, and I need to find f of 1. F of 1 plus h means take your function negative x squared plus 2 and plug in 1 plus h. So the only thing that we're going to change is we're just going to plug in 1 plus h and then plug in 1. So that's negative parentheses 1 plus h squared plus 2. That's just this first part that I plugged in, minus f of 1. Well, we just decided earlier that f of 1 is 1 because we looked at the graph or because we plugged it in. So right here where f of 1 is, I need to put a 1. And that minus sign comes from my formula. And I didn't mention this earlier, but this limit, the interesting thing about it is when we started off, well, we always have a problem because I can't plug in 0 here at the beginning because it gives me 0 on the bottom. Even here, I can't plug in 0, I have 0 on the bottom. So our process for the problem is going to be us working things out until we can cancel the h off the bottom, or somehow manipulate it so that it won't be just 0 on bottom. Maybe it'll be something else on bottom. So to simplify the top of this, we need to do 1 plus h squared. Now it's important to note that 1 plus h squared, you need to FOIL 1 plus h times 1 plus h. If you just write 1 and h squared and you think that's what it is, you're close, but still so far away because that's my first term, that's my last term, but I also have 1h and h, or 1h twice that I get from my outer and inner terms. So that means that this is actually 1 plus 2h plus h squared, and it's really important that you do that and don't forget about that middle term. Now that's what this part is. So I'm going to replace 1 plus h squared with 1 plus 2h plus h squared. But there's a negative in front of it, so I'm going to go ahead and distribute that negative into what I just got. So this is going to become the limit as h goes to 0 of negative 1 minus 2h minus h squared. That was all that needed to be made negative. Now I have plus 2 minus 1. Here's where we're going to start being mathematical with our formula. Negative 1, positive 2, and negative 1 add together to give me 0. This should happen because if it doesn't, we'll have a number left on top and we won't be able to move forward. So if you're working it out and you get numbers that don't cancel each other out, you probably are going to need to look back and see where you messed up because you probably messed up. We are left with negative 2h minus h squared over h. And at this point, what we're doing is we're basically factoring the top of this. They both have an h in common. So we can take out that h and get negative 2 minus h. And then cancel out the h on the top and the bottom. The other way of thinking about it is just anytime we have the same thing in all of our terms, we're allowed to cancel whatever that is out. So if one of these didn't have an h, we would be stuck. But since they both have an h on top, it's like we're dividing the h into those. So this leaves us with negative 2 minus h. Now I don't have a reason not to plug in h because I don't have it in the denominator anymore. So if I plug in h, this is negative 2 minus 0, which equals negative 2. That is my answer to part A, and what I just found was the slope of the tangent line at x equals 1. So that's actually the really hard and involved part of this problem. B and C are much easier. B asks us to find the equation of the tangent line. Well, what we need to find the equation of a line in general is we need to find the slope, which we just did. Our slope is negative 2. We also need a point that it's going through. If we had the y-intercept, we could use slope-intercept form, but it's not likely that we'll be given that. We'll probably, though, not probably, we'll definitely know a point because they want to know at x equals 1 what's happening. So the point that we care about is this one right here, 1, 1. because it's going to go through that point with a slope of -2. So I'll remind you really quick, point slope is y minus y1 equals m times x minus x1. And so we're just going to plug these in. Y minus 1 equals -2 times x minus 1. And we're going to leave it like that. We could solve this for y if we wanted to. We just don't need to, because I can actually graph from point slope just as easily as I can from slope intercept if I know what I'm doing. I know a point 1, 1 right here, and I know that I want to go down 2 and right 1 because of my slope. So here is my tangent line. I'm going to cheat and make my line look nice, so hope you don't mind. So there's my tangent line. It touches at x equals 1, has a slope of -2. So that's part B, and we've already graphed it for part D. Part C asks us, if you look up at the instruction, it asks us to find the equation of the normal line. And the normal line is just a different way of them saying that they want the line that's perpendicular to the tangent line. And so we need to remind ourselves what perpendicular slopes, how to get perpendicular slopes. So if our original slope is -2, a perpendicular slope flips and changes sign. So it'll be a positive 1/2 for our slope. It's still going to go through the point 1, 1, and so we can write this out really quickly. Y minus 1 equals positive 1/2 times x minus 1. Again, no need to solve for y. This goes through 1, 1, and then our slope says go up 1, right 2. So from that point that we are using, we're going to go up 1 and right 2. Now, what should happen, because in case you don't remember, perpendicular lines are the ones that meet at a right angle, 90 degrees. That's what this angle should look like right here. Mine looks pretty spiffy because I used really straight lines and stuff. And sometimes when you're doing it, if your graph's a little messy, it might not look exactly like a right angle, but it should look really close. Basically, you should know that, like, if you had accidentally drawn it like this way for my blue line, that's not a right angle. So that would have been a really big clue that you messed that slope up. So that is one problem. Now, that took a while. I'll agree with you there. And maybe not the easiest thing, especially part A. But what happens is that now, every time they give us a function that has x squared, our steps are going to be incredibly similar to find this slope at the end. So once we've practiced doing this a number of times, then even though we might still have quite a bit of work that we show, it won't be as bad because we'll know what we're doing and it'll make sense. But we've got to practice to be able to do that. We're going to do another one, and this one is a fraction. So I'm going to go ahead and graph it. This has a vertical asymptote at 3. So that's where if I set the bottom equal to 0 and solve, that's what I get for my vertical asymptote. It has a horizontal asymptote at 0, and then I can look at some points like 4, 3, 5, 1.5, 2, -3, and 1, -1.5. Those all come from a table of values, and I can look at my graph and say, okay, this is one of those deals where we're headed towards our asymptotes, like so. Now, the point that we care about is x equals 4. So at 4, up here on my function, when I plug in 4, I get 3. Or if I plugged it in over here, if I put a 4 where x is, that'd be 3 over 1, which is 3. So let's start off with our limit for a. Sorry, that's supposed to be an h, not an x. So we want to do f of 4 plus h minus f of 4 over h. So this is not going to have the exact same steps as what we just did because it's not a quadratic, it's a reciprocal function is what we call this. And once we've done one of these, again, anytime we see a fraction, it should be really similar. So I want to plug a 4 plus h in where this x is here at the bottom. And so that's going to give me 3 over 4 plus h minus 3. And then I need to do f of 4. So minus f of 4, which we decided was 3. That's all over h. Now I can go ahead and simplify in this denominator. I can do 4 minus 3 and get 1. So that's 3 over 1 plus h. 1 plus h does not combine because those are not like terms. And then this minus 3 I'm going to turn into a fraction because when I have fractions on top of a fraction, I need to get a common denominator so that I can simplify how many fractions I have. So to do that, the process is always the same. The first fraction multiplies by the second denominator. So this needs to get multiplied by 1. The second fraction gets multiplied by the first denominator. So I'm going to multiply it by 1 plus h. So that gives me 3 times 1, which is 3, minus 3 times 1 plus h. Now, it's really important that we think of this as a negative 3 that we're distributing, because if we only put the negative with the first part and not with both parts, then we're going to get really close to the right answer. We'll just have the opposite sign, which it would be silly to lose a point for having the wrong sign when you did all the rest of the problem right. So make sure you do minus 3 into this when you distribute. And on bottom, our common denominator is a combination of the two denominators we were working with. Now, a lot of this, like, I didn't necessarily have to write like multiplying by 1 or 1 times 1 plus h, like that 1 in front doesn't really matter. But if it had been a different number on bottom here, then it would matter. So now, notice these don't cancel, these 1 plus h's. A, because that's just bad math, because of this minus sign on top, we're not allowed to cancel things like that. And B, we just got that 1 plus h there on purpose, so why would we cancel it out even if we were allowed to? So our next step is to distribute. So we get 3 minus 3h over our common denominator. 1 times 1 plus h is just 1 plus h over h. So this whole time we still have this issue of if I tried to go and plug in 0, it wouldn't work. Now's the math magical part. 3 minus 3 is 0. I'm going to make h be over 1, and I'm going to flip my denominator and multiply. So I have I have negative 3h over 1 plus h, and I'm going to times that by the reciprocal of this, which is 1 over h. Now my h's cancel, and so I get negative 3 over 1 plus h. Now my issue with h on the bottom is not the same issue. Now if I plug in 0, I get negative 3 over 1, which is negative 3, which means that my slope at x equals 4 is negative 3. And then we'll do part B and C. So part B, we want the slope we just found is negative 3. The point it's going through is 4, 3. And we just need to write this in point slope. Y minus 3 equals -3 times x minus 4. So if I draw that, I start at 4, 3, and I have a slope of down 3, right 1. Yeah, it's probably just going to be easier for me to draw it anyway, so here we go. There we go. So there's the tangent line. Now let's do part C. We want the perpendicular slope to -3, so we flip it and get 1/3, and we change it from negative to positive. So our slope is 1/3, our point is 4, 3, so it's y minus 3 equals 1/3 times x minus 4. So it goes through 4, 3, and then I go up 1, right 3, down 1, right 3. And there we have it. So that's how we're going to do on page 92, which is our assignment. Problems 9 through 12. They have the same instructions as what we did on here, part A, part B, and part C, and part D. So